Hey guys, there's not really going to be an assignment associated with this, but it felt like it might be nice to have, or at least nice to think about. And I know some of you have expressed maybe a touch of boredom during maybe lack of activities that we're allowed to do. And so I figured I would make one last video just on using Venn diagrams for probability. So I'm assuming at this point that many of you guys have had a chance to use Venn diagrams in something like an English class, right? And you would say, okay, well, on this side, maybe you're talking about two characters in a book. So we use Romeo and Juliet. I don't know if you guys have read that, but I assume most of you guys have. Okay, and we've got the Capulets and the Montagues, something like that. And those are the two families, right? And so, there's two different, in the two circles here, okay, here's some things about the Capulets, here's some things about the Montagues, and in the middle, you might put, some things that are similar. So, like in the middle, you'd say, oh, well, they hate each other, right? And that's some common ground that they share, as strange as that may be. And you can kind of use that to look at things that are different between them and things that they share, right? Now, this is useful in uh, probabilities because we don't want to count events twice, right? So let's look at the example of, I'm pretty much going to use card decks today, so hopefully you guys are up to date on your card decks. But let's say that I wanted the probability that I get a face card and the probability that I get a spade. Okay, and so let's see how the Venn diagram would work. So big Venn diagram. Okay, and in this circle here, we'll put face cards. And over here, we'll put spades. Right? Now, spades is one of the suits. There's 4 suits, 13 cards in each suit. So there are 13 total spades, but 3 of those are face cards, right? We've got king, queen, and jack. So I've got, oopsies, 10 spade cards, ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Nope, not 1. Sorry. I was like, something looks wrong. There's no 1. 1 is ace. That's on me. Don't blame yourselves. All right. We also have a king, a queen, and a jack that are spades. Right? King, queen, jack. Now on the other side of the Venn diagram, we've got diamonds, hearts, we've got clubs, and then we also have spades, but we've already counted the spades twice, right? So if I counted the spades twice, then that would mess with my probability. And in terms of face cards, I've got king, queen, jack, king, queen, jack, and king, queen, jack, right? So what is the probability that I pick a face card? Sorry, that was supposed to be or. A face card or a spade? Well, now we can just count it up, right? So we can say, well, there I've got the chances that it's just a face card and not a spade are 9 out of 52. The chances that it's a face card and a spade, 3 out of 52. And the chances that it's just a spade are 10 out of 52, right? And so in that case, I would say that because they all have the same base, I can, or sorry, I mean denominator, not base. I can add them all together. 9 plus 3 is 12, plus 10 is 22 out of 52, or 11/26. Okay? Now, if I didn't use a Venn diagram, then you might say, okay, so what are the chances it's a face card? Well, if it's a face card, there are 3 face cards per suit, so a total of 12 face cards. And then you might say, okay, how many spades are there? Well, there's 13 of each suit, so 13 spades. And so if you go about that way, then you say you've got 25, 50 seconds chance, right? Well, what happened is you double counted that king, the queen, and that jack, right? So you counted it as a spade. You also counted it as a face card. So what the Venn diagram allows us to do is to take into account anything that might be double counted. Now, there's a formula for this, and it's not that hard, but truthfully, there's not really any reason for you guys to learn the formula. Are you going to remember it in 2 weeks? No, probably not, right? But if you understand the idea of what's going on here, then that's far more important than the formula, right? And so I guess one other thing is, why do I draw a box around the Venn diagram? Well, out here in the box is all the other cards, right? So they're my diamonds that are not face cards, 1, 2, 3, right? They're my hearts that are not face cards, my clubs that are not face cards. And so within that box, the entire sample space is contained, right? We've got all 52 cards somewhere in that box. They either fall into one of the circles, they fall into the intersection, or they fall into that that rectangle. And then all we're doing is we're just counting things up, right? So if I want a face card or a spade, well, then I count up everything that's in the circles that's a face card or a spade. Okay. I could have also said I want all the spades that are not face cards, right? And so then, we would have to take out the king, the queen, and the jack, and we would just look at the spades here. So by drawing this Venn diagram, it kind of allows us to more easily look at something like this, right? We could also do the same thing with dice, although maybe I should have started here because this will be probably a bit more simple. But I've got my entire sample space, okay? And I want to roll the dice, and I want to get something that's either even or prime, okay? You'll recall that prime is a number that's only divisible by 1 in itself, okay? So for example, 2, 3, 5 are all prime numbers if we're looking at the dice. So we've got 1, 2, 3, 4, 5, 6, and we want to put all of those in there somewhere. So we've got even, we've got prime, and in the middle we've got both. So our even numbers, we've got 2, 4, and 6. 2, oopsies, I wanted green, 2, 4, and 6, but 2 is actually prime because it's only divisible by 1 in itself. So I'm going to put 2 in the middle. 2 in the middle, right? The prime numbers, I want to look at numbers that are just prime. So prime numbers divisible by 1 in itself. Prime is not, 1 is not technically a prime number. I know that's a little bit strange, but it's only divisible by 1 in itself, but that's the same thing, so it's kind of a special case, and maybe there's a little bit of debate there, but we're going to choose not to count it as prime. You might hear otherwise in the future, but for the sake of this, we're not going to count 1 as prime. Okay, and so then my prime numbers are 2, 3, and 5, but 2 is already in the middle, so I only put 3 and 5. Okay, and so I've counted 2 somewhere, I've counted 3, I've counted 4, 5, 6, and 1 hasn't been counted anywhere, so that'll be outside of both the circles. It's neither even nor prime, right? And so if I wanted to say what's the probability of being even and prime, well, I've got a 2 in 6 chance of just being even and not prime. I've got a 1 in 6 chance of being both even and prime. And I've got a 2 in 6 chance of being just prime and not even. They all have the same denominator. So 2 plus 1 plus 2 is 5, 6. And we have a 5/6 chance of being a even number or a prime number when we roll the dice. Now, you might just say, well, that's kind of obvious. You know, I could just look at this and say, well, the only one that's not there is 1. So obviously it's just going to be 5/6. And I totally agree. I've complicated a more simple example, but you can see why that's a little bit why we do that when it comes to a bigger sample space, like something with the deck of cards up here. Right. Yeah. I think that is where I'll end it. Okay. I'm not doing a problem set with this because I don't. There's a lot of people that are relatively far behind, and if you are not, there's a good chance that you are doing very well in the class. I hope that you watch this, you find it interesting. If you do want to challenge yourself a little bit more and continue to do some math, for those of you that are going into pre-calc next year, something that you might look into is logarithms. And I can send you some good videos on these, so if you're interested, just send me an email. Logarithms, inverse functions, if I could spell, inverse functions. You'll want to practice your factoring. And you could also look at E, and we'll also see rational functions. So if you want to learn more about any of these, let me know, or just look around on YouTube. There's a great channel called 3 Blue 1 Brown, and I think it might be 3B 1B, but he's recently done a really good video on logs that talks about it, and I've watched it and really enjoyed it, and he's got some other good ones. Some of them might be a little bit high level, but it could be worth perusing. Obviously, Khan Academy's got a lot of different videos, and there are a variety of other people putting stuff out there. So if you're going into pre-calc next year and interested in starting to look into some things, then feel free. Otherwise, it's been a pleasure to have you all. I know it's been kind of a crazy school year, and if you need some time off, then take some time off, and I'm sure Mr. Barron will get you guys right back into it when August comes around. So as always, let me know if you have any questions. Hope you guys are all doing well. And if you don't hear from me again, then have a great summer.